Welcome to all. So now we are going to discuss about CMOS integrated circuits. So myself, P. Abdul Samad, me, Assistant Professor, Department of Electronics and Communication Engineering, NPR College of Engineering and Technology, NATHAM. So in this session, we are going to discuss about CMOS integrated circuits. So what is meant by CMOS? CMOS is a complementary metal oxide semiconductor. So it is an advanced technology of integrated circuits. So now in this session, we are discussing about what is CMOS. So uh, what are the integrated circuits are available in the CMOS circuits. So the contents of this session is the combinational and sequential circuits. The basics of IC, the basics of integrated circuits is a combinational or sequential circuits. We are discussing about the main differences between the combinational and sequential circuits. Then second one is static CMOS circuits. So static is a constant. So we are going to discuss about the static CMOS circuits. The next one is the combination of NMOS and PMOS is called a CMOS circuits. So what is an NMOS transistor? Then what is an PMOS transistor? And next one is threshold traps. So threshold traps means the minimum voltage to turn on the transistor. Transistors means NMOS transistor and PMOS transistors. The next one is CMOS logic style. So see which type CMOS we are used in this VLSI design circuits. Then last one is the example of NAND gate and NOR gate by using the CMOS logic circuits. Then first one is the differences between the combinational and sequential circuits. Then combinational circuits means the output of the combinational circuits depends only on present inputs, not for past outputs. So this is a combinational circuits. There is no memory element in this combinational circuits. Then next one is a sequential circuits. Sequential circuits means combinational logic circuits plus memory devices. So this is called sequential circuits. So in the sequential circuits, the output is depends on present inputs and past outputs, previous inputs. So in this the main differences between the combinational and sequential circuit is the memory element. Then static CMOS circuits. So static, we are already discussed. Static is a constant output. So in this VLSI design circuits, we are used for constant voltage. That is a 5 voltage. This is a constant voltage. So if the logic 0 means the output is the voltage is 0, then the logic 1 the voltage is 5 voltage. So that is a constant voltage. So in this time we are generating the constant voltage. The static CMOS circuits mean that every point in time each gate output is connected to either VDD or VSS. If we are going to connect it to VDD, the output is plus the output is 1. Then we are the connected output is VSS, that is called 0. So all digital signals are represented by ones and zeros. So 1 means VDD and 0 means VSS. So this is a constant, that is called static CMOS circuits. Then static CMOS, how we are going to represent the static CMOS. Then PMOS and NMOS, we are already discussing about what is a CMOS circuit. CMOS is a combinational the CMOS is a combined for PMOS circuits and NMOS circuits. So PMOS is a pull-up network and NMOS is a pull-down network. So PMOS and NMOS. So both configurations are available in the CMOS circuits. Then next, NMOS transistor. How the NMOS transistors are worked? That is a series connection or parallel connections. If two NMOS transistors are connected in series, the output is Y equal to X. That is A into B. Okay. the inputs are A and B, but the output generated A into B. That is a logical AND operation. Then next, if the NMOS transistors are connected in parallel, the outputs are A plus B. That is the logical OR gate principles. So this is a NMOS transistor connected in series or parallel combination. The next one is a PMOS transistor. PMOS transistors are connected in series. The output is A plus B bar. So this is a NOR gate principle. Then the PMOS transistors are connected in parallel. That is a NAND gate principle. A dot B the whole bar. So this is a series and parallel combinations of PMOS and NMOS transistor. In CMOS, we are going to connect these two transistors, NMOS and PMOS, connected in series. That is called NMOS transistor. For example, this is a threshold voltage traps. So threshold voltage traps between the source and drain. So we are already knowing about the what are the terminals of MOSFETs. That is a drain, source, and a gate. So the threshold voltage are generated from drain to source terminal. Then next is a CMOS logic styles. That is a pull-up network and pull-down network. So both networks are available in this CMOS designs. So A plus B the whole bar is equal to A bar dot B bar. A dot B the whole bar is equal to A bar plus B bar. So this is a De Morgan's theorem. So hence these theorems are proved in this CMOS logic. So AND gate is equal to NAND gate plus inverter. So in this CMOS logics, we are only designing for NAND and NOR gate. So by using this NAND and NOR gate, we are getting AND gate and OR gate operations also. So this is a basic logical circuit diagram for NAND gate. So we are connected both PMOS transistors and NMOS transistors are in series. Then PMOS transistors are pull-up network. So the circuits are upside. Then the NMOS transistors are connected in series. So that is a pull-down network. So these circuits are in downside. So both transistors, NMOS and PMOS transistors, are connected in series. So the connecting time, it is called output for A plus B the whole bar. So both transistors for both NMOS transistors are connected in series. For both PMOS transistors are connected in parallel. So the output is A dot B the whole bar. This is a NAND gate principle. The truth table for NAND gate are shown in websites. So both inputs are 0. Both inputs are 0. The output will be 1. Then any one of the output is 0. The output will be 1. But both inputs are high. The output will be a 0. Then next one is a NOR gate. So NOR gate is a both PMOS transistors and NMOS transistors are connected in series, but NMOS transistor connected in parallel and PMOS transistors connected in series. So this is a example for NOR gate. The output is taken at the middle of both PMOS transistors and NMOS transistors. Thank you.